This is a demonstration of using pen tablet, particularly this brand, the Wacom pen tablet. Its sensitivity is second to none. It's very, very sensitive. It feels as if it is writing on a piece of paper. And I'm particularly using the software GIMP to actually generate this image, but these are far better substitute. It's out there, but this is free, something I particularly like because it's sensitivity and all that, but it's very difficult to learn, so I don't recommend, but I got used to it. So here's the idea. Using the GIMP, you can create this blackboard background type of image, and you can change the color of your pen to the white color, and then you can write it like this, Wacom tablet. As you can see, it's very, very sensitive, as if I feel it, like I'm writing this on a piece of paper, and this particular software is called GIMP. So I'm going to go ahead and copy some of this content of a textbook in there and paste it into this GIMP. And I can make it a little bit bigger, and I can see it better there. Now, once you have that, now we can talk about the solution. You can always copy and paste any prepared sources there, so you don't have to write this one down. And you will explain, the range of this one. The domain is formed by these lines. So because it's a 3D, usually we orient three-dimensional space in this way, x and y, this way, so that when it's turned around, it's more natural to, I'm going to sketch it over there. So y varies from -1 to 1, so it's relatively over here, and a +1 there. X is from 0 to 3, it's roughly over there. So I'm going to use this dotted line to sketch the region. So you can see it's very natural. Over here, the x coordinate is 3. Now, I'm going to shade that region with the yellow color in there, like you do in the blackboard. So that's the region they're talking about. Over it, there is this function, x squared plus y squared. So I'm going to sketch this one using this kind of 3D view. I'm going to label that this point was A and that point was B. And I'm going to label that one as A and that one's B, so that it's kind of least amount of rotation is required to compare this 2D view to this 3D view over there. So that's that, and that's the origin right there. And at the origin is 0, 0. If you think about when x equals 0, this is where y-axis is there, and x coordinate is 0. What will be the kind of section over there? If you plug in x equals 0, it's just a parabola. So over there in that plane, the surface we're about to sketch is kind of this section over there. When x equals 3, if you put it in there, this whole thing is going to be 9. So y squared shifted up by 9. So let me move this over there a little bit so that I can create a little bit more space. So over there, so that's going to be same parabola but shifted way up. So it's far higher, but let me just use this one like that. So that's going to be the section. If you cut it through these two sections, you can see that's probably just another parabola. So I'm pretending that it goes through like that, and the other one is kind of connected to that. And the whole thing should go down to that origin right there. So I'm going to sketch it like this. I'm going to delete this part a little bit, and this is kind of dotted line on the other side. So you can shade that with a slightly brighter color there, like that. So that's the 3D effect we're creating using this grid mesh line over there. So that's the surface, z equals x squared plus y squared. And this volume thing they're talking about is everything underneath it. So hope you'll be able to visualize it, the volume underneath it there. So that volume V is going to be denoted by this double integral. It is not the iterated operator, it's just a compound symbol, and here's x squared plus y squared. And it's more standard D, it's a dA there. So that volume is that. And we calculate this one using iterated integral. So if we do y integral first, where x is fixed, y goes from -1 to 1. one there, and the function x squared plus y squared. And this time inside, we're doing this dy integral first. And that part is going to be where x is fixed, right? So x is fixed, or say x is constant. Maybe that's a better way to say that. And then once you have this calculated, and y will disappear, and x goes from 0 to 3, and dx and things like that. So if you can solve that integral, and that will be the answer, let me go ahead and copy this one over there. So I don't have to rewrite it. So let's focus on calculating this and stuff like this. So this must be calculated for y, integrated for y, where x is treated as a constant. Think about it. If this whole thing is 5, what will be the antiderivative? The antiderivative will be 5 times y. So here is constant, and here is the integral variable, and here's 1/3 y cubed. That's the antiderivative with respect to y. And this y value is emphasizing to ourselves what to plug in there, y equals 1. And here's a dx. So you calculate that, plug in this one, that's going to be the function of x. So here's 0 to 3. X squared is constant, so focus on y. Y is 1 minus the second value using the linearity of this, I call in my class bracket operator, but that's means something else in higher mathematics. So 1 and 1 is the same thing, 1 and -1 cubed, still -1. So that whole thing with no x in it. So that's dy in there, not dy, dx. Right now that's a function of x, and now you can go on and complete the calculation. So this is how it feels like using Wacom pen tablet, particularly like this blackboard effect, as if we were really writing on chalkboard. Thanks.